Hey everyone, I'm going to start off with a share right away. This deals with, oops, this deals with multiplication and division of rational expressions. Now, you should have watched the video before you do this. You should watch the video dealing with simplifying rational expressions because really this multiplication and division are really just an extension of this. So basically, let's review some things that we've seen before. So let's review just ordinary numbers like 4/5 times 9/8. Okay, so 4/5 times 9/8. Okay, basically what you learn is you can multiply straight across. 4 times 9 gives you 36, and 5 times 8 gives you 40, and you could reduce. Okay. Another thing you could do is you could note that, this whole business of 4 and 8, 4 goes into both. In fact, 8 is 2 times 4. That process was called factoring, if you recall. And the 9 is 3 times 3. Now, since the 4 matches with the 4 here, we can divide it out. In other words, cancel it away. And this gives us then just 3 times 3 over 5 times 2, or 9/10. Okay? Now, we're going to do that approach as we move forward. Let's look at an example with variables. Okay, in this one we have 5a squared over 14 times 7 over 10a to the third. So now the 14 is 7 times 2. So that means the 7 and the 7 with the 14 cancel out. The 10 is 5 times 2. So that means the 5 and the 5 here cancel out. Okay. A squared over a to the third, these will cancel, giving us an a. Okay. So I mentioned something about the domain. You saw about that in the video. The denominator cannot equal 0, so that means a cannot be 0. The first attempt was multiplying straight across. We get this big number. And we can divide it out and reduce. Or we can take a look at it this way. 35 over 4 times 35 is 140. The 35s cancel out. And a squared over a squared gives us a there. Or 1 over 4a. Okay. This is the preferred way. That's one way. This is the preferred way. That's the way you probably did it back in basic math. The preferred way is to factor right off the bat. That's what I talked about and started talking about. 5 goes into 5. Okay. 7 goes into 7. So we cancel the 5s, we cancel the 7s, and we cancel the a squared because a to the third is a squared times a. That leaves us with a 1 times 1 times 1, or 1 over 2 times 2 times a, or 1 over 4a. Sometimes the problems are a little bit more messy. Sometimes we have to factor. In fact, our first step when we multiply or divide is to factor both top and bottom of each fraction. So in this first case, I have a squared plus 4a plus 4. I need two numbers that multiply to be 4 and add up to 4, and that would be 2. So this is a plus 2 and a plus 2. The a plus 5 here really doesn't factor. Okay? Down here in the second fraction, I have a common factor of a. That's the first thing we should always look for. And we'll do that. We'll factor the a out. This gives us a times the quantity a plus 2. Down here, I would typically use the AC method. I'm going to shorten it up a little bit. If we recall the AC method, we multiply the 2 and the minus 10 together. That gives us minus 20. And we look for two numbers that multiply out to be minus 20 and add up to be minus 1. And that would be a minus 5 and a 4. Okay? We end up factoring a 2 out, regrouping and factoring a 2 out. And that'll give us 2a minus 5 and a plus 2. If you need work with factoring, you can practice that a little bit more. Always should think about that, though. You got to factor first. Okay. After we factor, we note any common factors, just like the 5s or the 7s above. We have a plus 2 and a plus 2. Those will divide out. And then we have another a plus 2 here and another a plus 2 here. Those will divide out. There's our first a plus 2 over a plus 2. There's our second a plus 2 over a plus 2. What does that leave us with? Well, that leaves us with a 1 here because everything in the top of this first fraction divided out. And that leaves us with a 2a minus 5 here because the a plus 2 will divide out. Over here, we have the a plus 5. Remember that a plus 2 divided out with the other a plus 2, leaving us with a. So this gives us 1 times a plus 5, or a plus 5, times the quantity 2a minus 5 times a. And I just rearrange that as a times 2a plus 5, or minus 5 in a parentheses. I can distribute that a times 2a minus 5, but I don't have to. Now, note, we cannot simplify any further. Okay, you can't simplify through the addition or subtraction here. You can only simplify through multiplication. So when it says a plus 5, this 5 is attached with the a. And if it doesn't match exactly down here, you can't cancel it. I know it's tempting, but you can't do that. So what's the difference between this and division of rational expressions? Not much. If you recall with rational expressions back in basic math, you wrote the problem out, then you rewrote the first problem, multiplied, and took the reciprocal or flip-flop the second, the old copy dot flip-flop rule. And then you multiply just like before. And that's exactly what we're going to do after we factor if needed. Now in this first example, we really don't need to factor much, maybe the numbers, but the variables really don't factor that much. And so we rewrite 5x squared over 9. We're going to multiply and flip-flop this to 27 over 15x to the third. Let's take a look at what happens. When we do that, we have 5x over squared over 9 times 27 over 15x to the third. Okay, now note, the 27 is 9 times 3, and the 15 is 5 times 3. So that means we can divide out the 9, and we can divide out the 5, and also we can divide out the 3. All of that divides out. The x to the third is x squared times x. So that means this x squared up here will divide with x squared down here, leaving us with a single x in the denominator. So let's see what we have. So the 9's divided out after we factored the number. The 3's divide out after we factor the number. The 5's divide out. And the x squared divides out, leaving us with 1 in the top over x in the bottom. So we get a 1 over x. This last problem, we need to factor some. Okay, so we have a 3x squared over x plus 2. The 3x squared, I'm not going to factor right at this moment. The x plus 2 can't factor. The 6x to the fourth, I'm going to leave alone at the moment. But the x squared plus 5x plus 6, that needs to be factored. And so we look for two numbers that multiply to be 6 and add up to be 5. And those two numbers are 3 and 2. Okay? And so we copy, we dot, and we flip-flop in factored form that x plus 2 and x plus 3. Now let's take a look at that 6x to the fourth. That's going to be, if I think about it, I need an x squared here. I'd like to match it up with the x to the fourth. Well, if I write x squared times x squared, I have x to the fourth. And then the 2 times 3, that's where the 6 comes from. Why did I do that? So I can match up the 3's. Okay. So let's see what divides out. So I have a 3x squared down here, dividing with a 3x squared up here. And that's going to cancel off. I have an x plus 2 here, dividing with an x plus 2 here. That's going to cancel off. That leaves things that don't cancel off, x plus 3 and 2x squared. And that's our final answer. Hopefully this helps you out a little bit, gives you a little bit of guidance. This is not an easy chapter to deal with. That's why it's a short chapter, and it's a quick chapter in our grand scheme of things. We need to know how to do some things here. However, we're not expecting you to be an expert at this. Take care.